Okay, guys, this video caught me, right? Let's talk about rafter ties, collar ties. I run into this with jobs, but this is in Canada, and I don't run into such a shitty roof like this. I've never run into a shitty roof like this. I guess this would be more like in a barn here for us. It appears to be multiple layers of roofing, some type of irregular sized bat type boards over type of 2x4. We're looking inside a roof, a hybrid a little bit, if you will. A hybrid to me means that it was something else and they tied onto it and made it something else again. How do I determine that? Is that we see shingles here. So this was an addition that was added on an existing structure at one point. And you could probably time it back to when they, in that area, when this was allowed, or if maybe it's always still allowed. There's no ridge board. This is Canada. And there's a ridge board here, but no bridge board here. This contractor, it appears it says, why structural engineers are awesome. This just popped in. Home renovation, do I? 907,000 subscribers. And so he states something here, and I went down to the comments after I watched, and I like reading comments sort of secondarily. I'm going to frame it the way I think my engineer is going to prove it. Should be the other way around. And this guy writes back to this guy, exactly. I'm a structural engineer, by the way, P-E-S-E, after my name. He doesn't give his answer why he doesn't like or likes or dislikes the guy's answer here. Let's take note of that, though, because you have to go that far into the video. But look at this wall system, guys. This is, let's just jump to the engineer first. And I'll jump around there because I want to do my narrative in this capacity. Let's do this. So this is the wall system. This would be your outer wall. We would consider it something like a knee wall. It appears that the rafters stop here, and on the outside it would be probably no overhang at all and transition on a face wall like this. Wallpapers, it looks like it was wallpaper there that was here at one time. So this was their finished look with no insulation at one point. This was a finished look. I don't know what the rest of the video looks like. I didn't make it that far beyond where I just showed you. This shit is just craziness. It's not continuous anymore. It's scabbed together, I call it. It's not continuous, even top plate, bottom, top plate. This is not even a cap plate at this point. You know, you have a top plate, then a cap plate. There's nothing tying this in. This is just, this will be shit work, I call it. This will be shit work. I don't care if the guy gets upset and you got somebody tracks him down and says, the guy said you got shit work here. This is shit work. Now, if the engineer signed off on all this shit work, well, then the engineer is approving shit work. He says he uses this company frequently. I don't know who did the electric here, but I don't know where that's legal any damn where. Let's go from there. I mean, that's already roughed in, really? You see the little bit sticking there, and then we got this crazy loop going here. Yeah, I don't see that shit going off anywhere.
Depends on the engineer. Depends where you live.
All right, now here's the engineer.
And sometimes depends on how the sun is shining on the day of the visit.
On the day of the visit.
Nothing about building old houses is consistent. That's for darn sure. Right, so we're just waiting for the structural engineer now so we can have our conversation about the collar ties. And then we can finalize our plans on the rest of our structure as soon as we have that all.
So basically, he's just guessed how the frame. He says he's just going to put it together and hope that the engineer approves his layout of this guest framing.
Finished out. Then
apparently, at this point, he put this 2x whatever whatever this material is out. It looks like it seams here. So that guy wouldn't even see it, but he should be able to extrapolate this shit is not continuous. But now it's got this nailed in with what nails I don't know, into this rotted out lumber, which we'll look at in just a minute. I mean, it's rotted out.
Then we will finish framing, and then we can insulate and get this all vapor barriered up. It'll be so nice to be.
So we're looking at that. See, looks like plywood behind it, and then this on top of it. So this thing is loaded. these 2x whatever this is, 2x4s, and then he loaded it again with his furring strips, and now he's going to load it with drywall. And I think this is Canada, you know, and this engineer obviously he's working with him somehow. I don't know if he only is working with him, but for this collar tie thing though, I don't know. I don't imagine that he approved this with the snow loads being greater in Canada than they are in anywhere in the United States. Here we go.
Be separated from the old.
And I can't think of I don't have any facts to prove that statement, but I don't think anywhere in Canada they have a snow load that's less than ours. I'm just trying to think of that. If you guys know, and I'm talking about the Canada above the United States, not if they own some damn province down in South America. All right, so here we go.
Old crud in the walls and the bugs and the dirt, be in the clean space. I just cannot wait. But first, we got to get the collar tie sorted out. So I'm here with my structural engineer, Ethan from Star Engineering. I've been using Star Engineering for the last few years. Ethan, this is the first time we've met.
Yes.
Okay, I usually was working in the east end of Ottawa, so I worked with the guys out of the other office. Okay. We're in the loft here, and we want to get rid of the collar ties, and that's these big things up here. And I was just having a quick conversation with Ethan about if I want to open the ceiling completely to the top.
So here's his collar ties, right? Oh, there's more electric in it. Huh. Okay. It just drops down. So just open it completely to the top is his question.
You're suggesting a ridge beam, and we can put one underneath all of the points of this ceiling?
Yeah, your best bet here is to put the ridge beam up right tight to the right underneath the peak.
Okay.
And then that will run all the way to the
outside balloon wall?
Yeah, the outside of the house.
No, that's balloon construction. How much?
And then he's going to tell him to carry it down, right? Carry the loads down this side and that side. Now let me show you what that looks like. So what Ethan, I believe, is trying to describe to him is a ridge beam that would be underneath. It would become a girder, if you will, and it would transfer the loads from the roof to the outside wall, down through the foundation and down through the earth, right? All right, let's come back to that. Let's jump over here now. But so we're going to fast forward, but I want to show you that. I want to show you another problem.
Just tie further down.
Okay, so the lower it is, the more strength you get. Yeah. So the more ceiling I want, the more engineering I need. Basically.
Yeah.
So if I was to sacrifice, let's say, moving the collar tie up 2 feet, okay, and put the collar tie in at that point, I'd be looking at going more like 2x10 or 2x12, maybe galvanized bolts 2 times.
That's the idea.
Is that a doable option?
It's something I'd have to design back at the office, but it's definitely feasible.
Bear with it.
Okay, so then I could go with a ridge beam. It's labor intensive.
So he wants no ridge beam, and he just wants to raise the collar ties up, basically, up top there.
Yeah.
Collar ties, rafter ties are a little different. All right, I want to show you that wall. Let me jump forward for a second. He's now got the insulation up here, so I'm definitely confused. This is that wall, right, that we just saw. He got up and said, let's speak to the engineer. So let's look at that. 1939, we're looking at insulation here. Now let's go back. So 1939, keep that in your coconut. Now, look at the wall behind his head there. This is that wall there with his paper on it. There's that piece of lumber. 1939, and we're going to go here. There's the wall. And wallpaper.
Be in the clean space. I just cannot wait. But first, we got to get the collar tie sorted out. So I'm here with my structural engineer, Ethan.
So he's there, and there's this plastic behind him now. There's that stud. Now let's go back one more time. Let me verify something for you. There is the box, the electrical box on the wall there on the floor. See it? 1939. Yeah.
Here, we're basically adding wood so we can get...
Bottom right here, there's the electrical box. This insulation is now up. And so what is he doing here? I would tell you this is what these guys do sometimes, the contractors. They do this, try to do this a lot to try to hide their work from true inspection. This guy's going to own it and doesn't even know what he's owning. In the video, you made it look like he just jumped up from there, and he obviously did an edit and then had the guy come out But before he came out, you now see this insulation in the background plugged here. See the insulation plugged up? Plugged in, rather. Plugged up, you know what I'm saying. There's this this section here above Ethan's head, this guy here, all right? So now let's go backwards. I need to triangulate this for you a little better. Hold on. Okay, so there's this mapping of the stain, and that's the siding, the old lap siding, if you will. It looks like lap siding. See it? That was the exterior of the house, and now it's got wallpaper on it as the interior of the house. That new thing. Let's go fast forward, and right about there. There's the mapping there. See the mapping back here in the corner here? 2 studs. Mapping this wall, this gap, right there, the mapping, and back again. Now you see the plastic's up. We come back here, we do this, we see the mapping, we see where he's going to say he's going to get up and talk to the engineer now, right about here.
But first, we get to get the collar tie sorted out. So I'm here with my structural engineer, Ethan, from Star Engineering. I've been using Star Engineering for the last few years.
And then all of a sudden, bam, the work that's being hidden from Star Engineering, apparently, was saying, is stuff like this. What the hell is this? So he's scabbing to this. He already cut it out. Now let's just look at that. Let's back it up. Let's show you what that looked like when he went at this thing.
Cool. Let's get rid of the top first.
This crap here. He's just tearing it off. Look at the siding. This is all gone. This is not structural anymore. Yeah.
You'll see.
What's holding the rafters up right now is the back of that plywood. But you see the gap on it? It's also taking the load of the, it's already deteriorated enough where it's already deflected away. Just where you see the shadow there from the underside of that sheathing. And the sheathing also the bat boards, I call them, you know.
That's just insulation.
So right here. Okay, so let's go for it.
Wow. Okay. So what's going on is every one of these boards is nailed from the outside into this. So the only way to remove it is to peel it off this way, but it's also nailed into that. And that's where the structural strength is. Everything's nailed in more than one direction. Woo! We might find that we're actually going to be in better shape leaving it alone and laminating this.
Wow. You know what you do, guys? You take a Sawzall blade and you just cut the damn thing. Reciprocating saw.
And then just rebuild. Understand that wood isn't the greatest insulator in the world, but it's not.
So he just cut out this huge section that was in the original. I had a top plate and a bottom plate, right? So a cap plate and a top plate. They're just gone. And now he's just going to make another patch section here. Just because he wants to.
And since we don't want to have to tear apart half the house in order to rebuild this, probably.
So that's what his intent is, not to tear apart the house. So to leave this crap, look at this. Leave this crap to just keep rotting out. He's just going to patch at it. Let's go.
Our only option at this point. The original wood here is actually 2x4, and it's an actual 4-inch. So what we did is grab some 2x6s and ran them through the table saw just to create an actual dimension.
So that gets a little bit worse now. He just made it one piece only. It's not even so they're not. Oh, come on.
Using a little bit over 3-inch clipped head nails. So if you put them on an angle, they won't fire out the other side. So now it's time to put in our new beam and tie it into the old structure. Well, this is where it gets interesting.
What I mean by, because you should lap this. It should be lapped so it. He's making two walls now, and what's holding these two walls together, and also the two roof sections now, are whatever the overlap is with this. With these, whatever this is, this flat, whatever lumber, or whatever you want to call this, and also the plywood, and I'm gonna guess that it's probably just shingles up there. But now you've got two sections here. It's tied in over here at the wall. Maybe they nailed this to the face there to some degree. So your span this might be your span from here to here. So there's your unsupported span. I don't know what this looks like more than that, but let's go from there. So that's your unsupported span. So this rafter needs to transfer the loads down, well, down this one, right, to make it over to it, and down this one would be fair enough, fair game to say your intent, you're transferring the loads, but ideally you just want to transfer it right down the way it was, because that's the grandfather part that's in, which the engineer speaks of grandfathering in. It's not grandfathered in to transfer the loads down left and right. It's only grandfathered in to be as is going down, straight down. Some building codes, and this is Canada, mind you, some people allow you to go ahead and replace like for like. Most of them, it depends on how bad it is. They'll say yeah, or some of them will say no. You got to bring that up. Give me a different 4x4 instead of the 2x3 here. Give me a 4x4 there, just because I want it.
You can see here.
So let's see how he transfers the load over. You remember the scab piece and a piece of insulation, and then
the difference in the thickness of two pieces of wood, old and new. What we want to do is we want to match the top.
So toenail, split wood, nothing. You get nothing out of that besides it's just tacked in place.
Over here.
×2.
Okay. That's temporarily in place.
Yeah.
Because it's bloom construction, they actually put the floorboards and cut around.
Balloon framing, guys. Balloon framing's got a different setup. So I don't...
On these beams. Just like doing a deck. And they're in our way. Two reasons. It keeps you from getting a consistent thermal break. Now when I insulate, I can actually get right down into this cavity from before. It also gives me a little bit of flexibility for doing all this. So beam balloon construction, our goal is to transfer load and to tie everything together with good nails that have shear strength that'll keep it all stable.
Okay. There should be you don't have to worry about shear strength on this, because the loads, balloon framing should be transferring right down to the foundation. You're not going to be having it under shear. It's going to be under compression. So if he's talking about putting this under shear strength, he's now trying to tie back into an existing member over here, which he didn't share with the engineer when he talked about it. He didn't say, look, I put up a scab, the 2x4 here, and I used whatever these nails are. That engineer didn't go on it. And then, it gets a little ugly.
And then you tie all the framing lumber together with the siding, the original wood siding. So we're actually going to bring support up to underneath the new plate here.
Let's see it. Come on.
The way I'm going to do that is by adding a...
So he added it to that rotten out wood right there. He just added the scab to it. And you saw the gap there.
I'm having issues with getting enough leverage to...
Right here. That huge ass gap. So the floor, the roof loads, snow loads can creep down to there.
Twist that board and get it in place. That's what I'm going to do.
So you have an issue with trying to twist that board. Yeah.
So I'm going to add this board on the side.
Let me just move on, guys. This is triggering me too much. I'm triggered too much. Let's come here now. Let's fast forward. So this is what he decided he could just do. Just chop off the end, sister about this much of it onto the existing material. This shitty craftsmanship right here of all the loads of that roof load will now be point loaded onto where it's contact here. That's your contact points. This is just fucking nasty. This guy has a channel with 100,000 people following him. Oh shit. Correction. I'm obviously on crack. 1 million people following his shit. And this is just triggered me beyond belief. All right. So let's just fast forward. You see this shit. This just triggered me. I mean, you guys come to this video and look at it. I could beat this up every fucking second of it. let's just jump there. You saw what he did. He then hid this nasty shit from the engineer with this insulation. Let's go to it. But he made it look like to the regular viewer, that he's being Joe Honest. Here we go, watch.
So we're just waiting for the structural engineer now so we can have our conversation about the collar ties. Then we can finalize our plans on the rest of our structure. As soon as we have that all finished out, then we will finish framing, and then we can insulate.
Right there. And then we can insulate.
And get this all vapor barriered up. It'll be so nice to
Then we can insulate.
be separate.
Then we can insulate, and then we can vapor barrier up. Let's go back to that again. So he knows the right thing. Listen.
Depends on the engineer. Depends where you live.
No contact. Here we go. Right there. Look at the gap.
And sometimes depends on how the sun is shining on the day of the visit.
Okay, so here's a scab with. He should. Remember, I'm just going to be out in a few contractors now. About cheap bastards and everything else, and and just shit work. So right there, look at that. There's insulation there. So it's he won't even pay for the real material to do it. The lumber. This is just incorrect. Even if you made it the full length, it would still be incorrect.
Nothing about building old houses is consistent. That's for darn sure.
This is the hide now.
Right, so we're just waiting for the structural engineer.
Now we're just waiting. Now all of a sudden, hocus pocus, this shit's going to be covered over. Here we go.
Now, so we can have our conversation about the collar ties. Then we can finalize our plans on the.
And now his whole scab is hidden. That on the other side, you can't see it because he put this piece here. He cut that out, as you remember. It's now going to be visually hidden from the engineer also. Here we go.
Rest of our structure. As soon as we have that all finished.
Except for that shit there won't, daylight.
Finished out, then we will finish framing, and then we can insulate and get this all vapor barriered up. It'll be so nice to be separated from the old crud in the walls and the bugs and the dirt. Be in a clean space. I just cannot wait. But first, we get to get the collar tie sorted out. So I'm here with my structural engineer, Ethan from Star Engineering. I've been using Star Engineering for the last few years. Ethan, this is the first time we've met.
Yes.
Okay, I usually was
Now
working
look in the
with
background.
East
All
End
of a sudden, hocus pocus, insulation's up and vinyl. And the vapor
of Ottawa,
barrier.
so I worked with the guys out of the other office.
Okay.
Okay. We're in the loft here, and we want to get rid of.
I'm getting you over here now. Here we go. Fast forwarding over here a little bit.
Way down and supported on the foundation.
Now look at that. All blocked out. All visually not seen, all, including the scab part. All hidden.
Foundation. So the last floor joist in this package won't be good enough. It has to go right to the foundation.
So it can be done in two separate.
I'm going to
posts.
fast forward.
Okay.
I'm going to fast
I've
forward.
actually seen a couple of different options. I've seen people put in like
Right here.
steel
Let's go here now. Right here.
or we could maximize a little bit of headspace and get more of a 9 or 10 foot ceiling here.
Come on.
Or something a little bit simpler. Okay. I'm going to probably look at both options just because I'm curious.
Then I'm going to hit
we
you right
can
here.
definitely look at both.
Oh, awesome. And is there anything, like what we're doing over here, we're basically adding wood so we can get proper insulation, and we want to go to R20.
Yeah.
Okay? But we're adding this 2x4, and this 2x2 here, we actually cut it on a 45 so that all of this downward force is sitting against that wall. We're just trying to give a little bit more rigidity in this thing.
So we know that he's trying to do the disclosure, right, to this guy, that he signs off or believes it. In reality, he's not telling him that he cut the rafter apart and that he did that. And over here, he's trying to say, just trying to get a little more rigidity in it. Reality, it was rotted out, and he cut it out. But he pointed to this one, and here's this one. Here we go.
That doesn't factor into your equation at all, does it?
It's really not, because these roof rafters now, we're not changing the span at all.
So it comes to
So
span and load and
Everything
winter.
is kind of grandfathered in because we're not adding anything new.
Okay.
So because it's existing, we
And we know that's not existing.
keep the support essentially the same. So it's supported at the top and at
Now
the
let's
end.
jump over
Okay.
here.
So anything you add, whether it's to increase the insulation or just add some extra
That
nails
doesn't change your math.
and rigidity, it's not going to change.
Add some extra nails and rigidity, is what he stated. But what the real deal is he structurally changed that wall there. Then he hit it, and so it's not just a freebie. That is not a freebie. What he did, that was a structural repair, and it was lacking.
Change any design that I
Okay.
have to do.
A quick question, because I have a crazy plan for the future, Ethan. I would love to cut a piece of here and open up a dormer.
Okay.
All right?
Yeah.
If I'm thinking of doing that in the future, is there anything I should do now in advance of that so that the structure's in place? Like if I was to put in a dormer starting tomorrow, what does my structure require? Obviously, 2x6 doubled up.
You're going to need a double up at each side of the dormer. That's
Each
right.
side.
He's telling him 2x6. Well, this engineer should be saying, well, basically this is all shit. And then what size dormer would it be? And the load still need to transfer down. So this is just shit. That engineer, that guy's a young boy there, young kid, young man, whatever you want to call him. He should say, this is shit, man. You need to, if you plan on putting a dormer in here, you need to, consider tearing this fucking roof off and redoing it. At least across the dormer to both sides. But where I think he's lacking, this engineer here, is he's only going to talk about the one side, the load being on one side. Remember, I showed you that roof. The initial part of this roof, it's no ridge beam there. The loads don't transfer down. They transfer by helping each other, left and right, left side, right side with this system. Also stopping it from kicking out, this wall kicking out when the loads are on it. Part of the pitch of it, and also the collar ties, as people call them above, the rafter ties. The floor ties would down here that we're standing on, that keeps that wall from going out, this wall. It's balloon framing, so it's got some side loading of the floor joists onto these members that he's standing on. But it also helps stop kicking this out. Let's go from here. You can see how the loads transfer down right here, 1 to 1. The roof transfers down here and it goes down to the foundation. You just can't pick anywhere you want and just say good to go. You want to make sure that load is going to transfer down the foundation. But let's go over here.
So anything across where I'm going to cut and pivot?
I have no idea.
Like let's say I want to go to 8 feet and then that's where it's going to lift from.
Yeah, so you'll have a cross beam wherever the dormer stops.
Right.
So it'll go, let's say, from here
across.
You go across 2 or 3,
And is that a double as well?
Want it to be. Again, it depends on the loads.
Okay.
So it'd be something I have to design.
Because now that rafter, that loads of the roof, the design of it, well then with that cross beam, we'll be transferring this load to where it connects, here, and the other one is yet 2 or 3. And obviously these are not designed. They were back then even, they had some brains, a lot of brains about them. They were not designed to take a dormer load. This was pushing the limits for what you see here. It was probably wooden shingles with this spacing like this to allow it to air dry. When they do spacing like that, it allowed the shingles to air dry. Here we go.
Design.
Sure.
But you're more than likely going to be good with a double 2x8.
Okay.
Something in that range, but it would have to be engineered.
So if I was to cheat and put in double 2x6
When he says cheat, he means put him in already. Listen.
after the collar ties are gone on both sides, and then cut across a double 2x6 with joist hangers, so that
He tells him 2x8. He says double 2x6. This is how crazy people are.
next spring I can call you up and say, hey, this is what I did. Can I open this up? Are you going to need me to pull the ceiling open, or if I take pictures, is that enough, or should I engineer it now?
It should be engineered now.
Okay.
Okay, I'm done with that. The guy's crazy. He told him 2x8 and he's saying 2x6s. Let's go to here how he says he's going to try to guess how the engineer would want it. And you can hear he doesn't even, the guys tell him 2x8s and he's saying 2x6s.
Structural engineer, we have got a lot of different options that we can employ here. We can put in metal brackets at the peak. We can remove some of the collar ties and double up in certain areas. We can also beef out our wall here, which is what we're going to do with 2x4s horizontally. So we get a lot more strength in this wall so it doesn't bow and flex. And that can reduce us down to needing only maybe 2 of them. So what I'm going to do is I'm going to frame it the way that I'm pretty sure my engineer is going to approve it. And
I'll stop you there. So he's going to do something first and then get the engineer to try to do it. These are the way these jackasses do it a lot. Let's jump forward. And he wasn't honest with him about all that. He hid it from him.
it's going to be a solid
Per the video.
week of structural framing, and I really don't want to bring all this back down to the foundation
Let me
wall.
jump forward now.
All right, here. This will work.
Now let me just jump forward. All right. So the guy gave him approval, as he stated. There's see right up here above us here for so high, he's just reduced it down and putting it here. And I don't know how many he's going to do or not, but that gives him the height. It's all academic at this point. And we go from there.
There's our line.
There's the electric again. Looks like it's been moved one more time from there to there.
I like that.
Okay, so let's go back to this and just, you guys, all right, let's see if I can help you visualize this. If you were to stand here, right, on top of this ridge board here, all the loads would transfer down here pretty much. You're not going to engage these rafters with your load here. Well, it's the same thing. These rafters are going to do two, in this capacity, they're going to work two ways. When you try to load them here, they're going to try to side load, trying to push out the one on the other side. That will counterbalance it and pretty much put all the loads, pin the loads and redirect them. How about that? That they'll be out here trying to push out. A little bird's mouth there. Trying to push out. Of course, it's secure, so it's not going to push out. It's going to have some side loading on the nails there, but the loads pretty much, because of the bird's mouth, and I love, you're going to have a little fun with you guys. The gravity, right? Your gravity is going to still want to push this downwards, and so your deflection is going to be in the middle. It's still going to be loaded just like a floor joist, if you will, as you load here, and your deflection will still be in the middle. And what's stopping it from just falling away, obviously, this end here. And you need the other side, because you can imagine if I got rid of all these guys here and just left one. See, I just left one of this rafter here, right? And I got rid of all of these rafters on both sides. As I loaded here, it would put a side load on this beam, and it would deflect away, which would just change the whole dynamics of the whole connections. So the opposite side helps keep that in balance also. So these are in balance. You just can't, for fun, put a dormer on this side if you want to, because the snow loads are going to be different on a dormer more than likely than this, unless you match the pitch. Let me see. If you could match the pitch of the roof, you'd still be in trouble, because it would still meet the roof here, and the loads would still be greater than typical on the rest of the roof. So it does matter how large the dormers are, how it's transferring the loads over to your ridge beam and to the other side. As you can see, no ties are required here. You have other ways of transferring the loads down, stopping deflection, such as this wall here. This is obviously a living space to me with this great height here. It's going to be a living space, and I'm not sure how they're going to resolve that look. I don't know. So just giving you an idea of what that looks like intent-wise. I don't know if you followed that or not. Again, if you remove all of them, you'll see what I mean about it. If you had a longer span and you were in the middle, you could deflect this thing all the way out. It's not going to deflect. Not this guy, not with your load. But it's a theoretical load, could deflect it all the way out, and you would lose your connection here, and the board would kick out at the bottom, and you would fall to the ground, to the next level. All right, so that's what I'm referring to. The closer you are to the wall there, obviously less deflection. And if you guys ever put these together, if you ever put a roof together, you know what I'm talking about, how you balance them on these two. You can hold the ridge beam up. It's kind of cool. You can hold the ridge beam up after you tack it like this. With just two on each end, and you work your way down, keeping the ridge beam very straight. Keep it straight. All right, but ridge beams are not required. They're not. You can get away with, depending on how you engineer it, with the spans. Like right here, look at that little span. You could tie that directly in, but no one's not using ridge beams. I'm sorry, they're not required in this old construction here, as you can see. We're talking 19. I forget when they changed the ridge beams. The ridge beams will be installed when the code just ran for it. But the craftsmanship, I'm telling you, back then is beautiful. Beautiful to watch these houses with no ridge beams. You can see how they're going to act independently without the ridge beam. So I could take a sledgehammer and pound on this, and it would break it out to here and here, but it's now independent. It doesn't have that interconnection. So this is stopping part of that wall from kicking out, this tie, but it's local. So this is going down here and down here to that outer wall that we know down there, right? And so like a little knee wall. It's local. It's not tied in with the rest of the ridge beams besides the flooring, these boards, these bat boards going across, along with the sheathing. I'm not going to count anything for this for the roofing, the asphalt, or wherever it may be. I'm giving 0 for that. But this is good. You know, just looking at this, that wall's pretty stable. As you look at each ridge beam, the walls are stable as hell. I mean, as you look at the ridge the rafter ties the rafters where they tie in at the ridge area. There is no ventilation up here. There's nothing there. No daylight seen. Here's the ridge beam 1x material. So it's interesting, the craftsmanship that that they jumped around here. That they jumped around. That they did a little mini ridge here, and then they just dumped the ridge beam out here. 2 different carpenters, I'm guessing, worked on this. All right, take care. I'm out. Hope you enjoyed whatever.